Okay, here's some help on the homework. And we're solving all of these equations over the interval from 0 to 2 pi. So we're finding all the answers that are in that interval. Starting with number 1, we're going to divide both sides by 2. Sine of theta equals square root 3 over 2. And then take the inverse sine of both sides. So theta equals inverse sine of square root 3 over 2. That means we're finding the angle whose sine is square root 3 over 2. And that is positive, and sine is positive in quadrant 1 and quadrant 2. So then we can label the triangle. Sine would be opposite over hypotenuse, so square root 3 on the opposite and 2 on the hypotenuse. We recognize that as our 30, 60, 90. And so the reference angle there is 60. So one answer is 60 degrees and the other answer is 120. But we're not answering in degrees, we're answering in radians. If you're like me, you just think in degrees first and then you can convert to radians. 60 degrees is pi over 3 radians and 120 is 2 pi over 3 radians. Okay, number 2. 5 tangent x plus 5 equals 0. All right, let's start by subtracting 5 from both sides and then dividing both sides by 5. Now we have tangent x equals -1. Now we take the inverse tangent of both sides. X is inverse tangent of -1. Okay, so you ask yourself, where is tangent equal to -1, or where is tangent negative? Tangent is negative in quadrant 2 and quadrant 4. So we're going to have a reference triangle in quadrant 2 and a reference triangle in quadrant 4. If tangent is -1, you can think of that as -1 over 1, if you want it as a fraction. So that tells you that your opposite is 1 and your adjacent is -1 when you're in quadrant 2, or when you're in quadrant 4, your opposite is 1, a -1, and your adjacent is +1. So what's your reference angle? That's a 45-degree angle in that triangle. So then our answers are oops, I'm going to try that again. That's a 45-degree angle. So our answers are 135 degrees and all the way around to 315. Let's convert those to radians. 135, so that's 3 times 45, so that's 3 times pi over 4. 3 pi over 4. And 315 is 7 times 45, so 7 times pi over 4 is 7 pi over 4. Let's do number 3. 2 minus 2 sine squared theta equals 0. All right, I'm going to divide both sides by 2, and I get 1 minus 1 sine squared theta equals 0. If you didn't divide by 2 there, if you divide by 2 later, it's still fine, it'll work. Now I'm going to add sine squared theta to both sides. But wait a minute, let me say something. This is one of those equations we could actually do 3 different ways. We could, if you look back at example 3 from the notes, I did it 3 different ways. The same is true for this one. Now, you're probably not realistically going to do it 3 times unless you're told you have to, so just pick a way, and I'm going to pick a way. I'm going to add sine squared theta to both sides, square root, which is going to give me plus or minus 1, and then I'm going to take the inverse sine of both sides. So theta is inverse sine of 1 and inverse sine of -1. The angle whose sine is 1, let's picture this. We must be on the unit circle. We're up here at the point 0, 1, so that would be 90 degrees. And the other one, the angle whose sine is -1, we're down here on the unit circle. That would be 270 degrees. Now let's convert those into radians, and we get pi over 2 and 3 pi over 2. Number 4. Tangent of x minus square root 3 times 2 cosine x plus 1 equals 0. Okay, so let's set each factor equal to 0 and solve each equation. So for the first equation, we'll add square root 3 to both sides. Tangent x equals square root 3. Then we'll take the inverse tangent of both sides. X equals inverse tangent of square root 3. You can think of it as square root 3 over 1 if you want to. So that's positive, so tangent is positive in quadrant 1 and quadrant 3. Tangent would be opposite over adjacent, so square root 3 over 1, square root 3 on the opposite, 1 on the adjacent. You can make them negative in quadrant 3. So what angles are we looking at here? That would be a 60-degree reference angle. So one answer is 60 and the other answer is 240. Let's convert those to radians. And we get pi over 3 and 4 pi over 3. Okay, we have the second equation, 2 cosine x plus 1 equals 0, so we'll subtract 1 from both sides, divide by 2, and then take the inverse cosine. Now, where's cosine negative? Cosine is negative in quadrant 2 and quadrant 3. Oops, that's okay. So the adjacent would be negative 1 and the hypotenuse would be 2. And so the opposite side would be square root 3. So we're looking at another 60-degree reference angle. So one of our answers is 120 degrees and the other answer is 240 degrees. And then we convert those, into radians, and we get 2 pi over 3, and we get 4 pi over 3. Okay, notice we got 4 pi over 3 for 2 of these, so really we only have 3 answers altogether. We don't need to list 4 pi over 3 twice. So our answers are pi over 3, 2 pi over 3, and 4 pi over 3 when we put those together. Okay, let's take a look at number 5. So we have we have 2 sine squared theta plus sine x minus 1 equals 0. So we're going to factor this. It factors into 2 sine x times sine x for the firsts. And for the last, we're going to have 1 and 1. And then let's see what the signs are going to end up being. We're going to need a minus 1 and a plus 1 so that we end up with the correct middle term when we FOIL. And now we'll set each factor equal to 0. So 2 sine x minus 1 equals 0, or sine x plus 1 equals 0. So for the first one, we're going to add 1 to both sides, and then divide both sides by 2, and then find the inverse cosine. Sorry, the inverse sine. Wrong function. Inverse sine of 1/2. Okay, so where is sine positive? Sine is positive in quadrant 1 and quadrant 2. Sine is opposite over hypotenuse. So the square root 3 would be on the adjacent, so the angle would be 30 degrees. And so the other one would be 150. So our two angles are 30 degrees and 150 degrees, but we're going to convert those to radians. And we get pi over 6 radians and 5 pi over 6 radians. And don't forget, we still have the second equation. So we have sine of x plus 1 equals 0. Subtract 1 from both sides and take the inverse sine. X equals inverse sine of negative 1. And that's going to be quadrantal. Picture your unit circle. You're down here at the point 0, negative 1. And the sine of 270 degrees is negative 1. So x is 270. Convert that to radians. And we have 3 pi over 2. So we have 3 answers. We have pi over 6, 5 pi over 6, and 3 pi over 2. Number 6. I didn't give you an example like this, but I did give you a hint. Factor out the GCF. Notice how both terms have a factor of cosine theta. So let's factor out cosine theta. And the other factor will be sine squared theta minus 1. So now we set each factor equal to 0. Cosine theta equals 0, or sine squared theta minus 1 equals 0. So for the first one, theta would be inverse cosine of 0. So where is the cosine 0? Think about the unit circle. Cosine is 0 at the point 0, 1 and at the point 0, negative 1. So that would be 90 degrees and 270 degrees. Convert those to radians, and we have pi over 2 and 3 pi over 2. Now for the other equation, there are several ways we can do this, just like going back to, what was it, problem number 3, I think. There are several ways we could do that. One way is just to start by subtracting 1 from both sides. Sorry, add 1 to both sides, and then square root. We get sine theta equals plus or minus 1, and then find the inverse sine. So we have inverse sine of positive 1, and we have inverse sine of negative 1. Now think about this. Where is sine positive 1? That's quadrantal, and that is up here, the same place that cosine was 0. So we get the same answer again. For that, we get theta equals pi over 2. And then where is sine negative 1? That would be down here at 270 degrees. So we get 3 pi over 2. So we got an answer of pi over 2 twice, and we got an answer of 3 pi over 2 twice. We really don't have to list them twice, so I'm just going to box one set of answers. And finally, number 7. Let's add 2 to both sides, and we get sine of x equals 2. Are your spidey senses telling you something yet? If not, that's okay. Just keep going. Take the inverse sine of both sides. X is the inverse sine of 2. Getting anything yet? Feeling any tingles? No? That's okay. We can keep going. So think of 2 as 2 over 1. Sine is positive in quadrant 1 and quadrant 2. Nice right triangles, huh? So sine would be opposite over hypotenuse, so 2 over 1. Now are you getting it? It's a problem, right? You can't have a hypotenuse of 1 with an opposite of 2. That makes no sense. No soluzione.